we think of the cornea as actually a bit like frosted glass that's been etched to be frosted. You
Mm.
pour water over a frosted glass, it becomes clearer to look through. And the corneal surface is very similar. So we need this tear film to create this nice, clear, uniform surface. And if we don't have a clear, uniform surface, then we get blurred vision. And so some people might come in thinking that they have a refractive problem or a focusing problem, when in fact they have a problem with their tear film drying out in some way. Now, one of the most common issues with the tear film drying out is often just because we live a modern life and we're not blinking enough. And we need that lid wiper action to wipe the tears across the front surface. Or we're doing it where we're not actually blinking fully. And so we get part way and we leave this kind of this area to dry out and get exposed. And, we often get remarkable improvements over several weeks of just getting people to become more aware about how they're blinking. And one of the easy bits of advice is a dozen times a day, take the moment to do 10 to 12 good blinks. And a good blink is not squeezing your eyes shut. A good blink is just making sure they close. And then that way we get that lovely scissor action of the eyelid, sweeping stuff out of the way, and also spreads those good oils off the tear film to keep everything nice and clear for us.
Yeah, it seems to be like something that I've noticed more people talking about in recent years, the whole dry eye disease or dry eye syndrome. And I think it's really come to prominence since the pandemic to some extent. Maybe it's because, we're all spending more time looking at computer screens during those, those lockdown years. But it seems like that more people are aware now of dry eye and how that affects their vision.
Yeah, and we're certainly seeing it in younger people than we did. It used to be something that was sort of an age-related issue, but we're seeing dry eye at all ages and including in kids. And so you'd have to sort of look at the modern life and exposure to digital devices and
Mm,
things like that being part of the
mm,
issue.
mm. All right, so that front of the eye, that's the cornea. That's the first window that the light passes through, if you like. Now, what is astigmatism? Because this is a word I think that gets thrown around a lot, but I'm not sure if everyone actually understands what it is. So tell us about astigmatism.
Yeah, look, it's an interesting too because there's a lot of layman terms for vision problems out there, and astigmatism is one that's not a layman term. It's actually the proper term, but I think it still gets kind of confused.
Hmm.
The vast majority of astigmatism is actually from the cornea, and we generally like to think of the cornea as is typically fairly spherical. Okay, so the same curvature all the way through. Now the reality is it's slightly barrel shaped, and so if we think of a barrel, it's quite curved this way, but it's flatter that way. Another example might be a dessert spoon shape rather than a soup spoon shape. And once you go outside a normal range of differences in curvature across compared to up and down, or even obliquely across this way, then you start to get the spreading of the optical image. And so if you've got a high amount of astigmatism, then you can't get a sharp single kind of plain image at the back of the eye, and the image tends to get spread. And so some people might interpret that as blur. When you're younger, though, you can kind of quickly focus across through the image spread and move that image around and slowly process it over time. So some people find that they can see, but it seems to take a while to come into focus. And other people might get starriness of lights. You get these sort of lines appearing through lights at night. And that could be caused by aberrations, but a more common type of aberration is actually astigmatism.
Mm. And so that's
And
something that glasses and contact lenses can correct for. Is that right?
absolutely. So if astigmatism is bothering someone, then yes, we can use glasses. We can use contact lenses as another way of correcting it. Where astigmatism comes from is an interesting one. There are certainly inheritable profiles that you see. There was a very interesting group of studies done several years ago where they looked at professional orchestral musicians. Now, if you perform in an orchestra and you're, as an example, first cello, you practice and perform in the exact same location with your stand in the same place and your head position and the conductor always in the same place. And you can and because you're practicing for hours and hours and hours in those positions, you might find that your head is turned a particular way and your eyes are pointing a different way, and they could almost predict from your common head position and your gaze which eye was going to have more astigmatism than the other. And so there is some indication that the way we use our eyes might be responsible for some astigmatism development. Part of the challenge is once it's there, it's very hard to undo. So, postures, and it brings around posture being an important part of moving symmetrically, sitting symmetrically, just to try and, if that is an influence on astigmatism development, it's all the more reason to take breaks and make sure you're sitting up straight and sitting well and looking after yourself. Yes. And then you've got irregular types of astigmatism, which we've talked about before, things like keratoconus and pellucid marginal degeneration, and you're getting into more diseases that create irregularity where it becomes a lot more difficult to correct the astigmatism with glasses, and you have to start getting down into special types of contact lenses to correct those things.
Sure. Okay. Well, that's interesting. So when you get someone in your consultation room, do you ask them which section of the orchestra they're in, the brass, woodwind, or string section?
Well, look, and we've got the benefit our practice has been around for a few decades now, and if you've got a patient who we've been seeing for quite some time and they start developing some asymmetries, astigmatism one eye more than the other, I do ask questions of, have you changed your setup of your workstation? Have you now got a screen off to the side? Are you sitting side on a bit more? So, I do ask about those things in some situations. Absolutely. Yeah.
I didn't realize that astigmatism is something that you could actually develop. I just thought it was something that you were born with.
Yeah, no, it can definitely develop.
All right, so that's the cornea. Now, in your model there, you showed us the lens, and that's like the second window, if you like, that it passes. Yep. Can you tell us more about how that works?
All right, so it's basically the basic format is that you've got the ciliary muscle here, and you've got this elastic bag that's suspended on little strings called zonules. And then you've got cells inside that are lined up in really regular lines. And it's that regularity that keeps it clear. Now, the idea of the lens is that the ciliary muscle will contract and you get this change in shape in the lens. And so they call that accommodation. And so the idea being is that we have, like I was saying, the cornea does the main getting the image close to the retina, and then the lens helps us adjust depending on what distance we're looking at. That lens changes shape in order to adjust the focus at near, and that's the one thing that we, like other parts of our body, we lose flexibility as we age, and we lose flexibility in that lens, and so adjusting our focus from distance to near becomes more difficult as we start to celebrate anniversaries of our 39th birthdays.
So like if you're using a digital device a lot and you're looking from a close screen to something that's on the other side of the room, and you're doing that a lot, do those muscles, I think you called them the ciliary muscles, do they sort of like get tired? Is that what leads to eye strain and other sort of like, is that the cause of what they call digital eye strain?
Yeah, and so the accommodation system, I mean, the whole visual system is designed to search the environment for things that matter to us, for survival sort of purposes. And our visual system was developed for moving through the world and not sitting still looking at two-dimensional screens. And so one of the ideas that I think fits most is that the ciliary muscles are not really designed to hold posture and hold focus for long periods of time. And so you get this fatigue that sort of sets in. And you can get some obvious changes in when we look at patients where the focusing's fatigued and someone's under focusing, or they might be pushing their focusing really hard and you see that they're over focusing, and it's all a reaction to the brain detecting that something's going out of focus. But what you also see, and the research is kind of starting to show this a bit more, is that we get these kind of changes in the fluctuations in the ciliary muscle. And that's one that's probably linked to asthenopia, which is visual discomfort, digital eye strain. I like to say to patients, eye strain's not a new thing. It's just a new thing to more people. If you're an academic, you are often reading books and potentially getting eye strain and potentially myopia. And if you weren't academic, you're outside playing. Whereas, it doesn't matter what your level of ability is now, you're on a screen.
Mm.
And so, that has made eye strain a much more common thing.
Mm.